What's up, advanced math students? What we're going to do today is continue our discussion of sequences and series a little bit, but we're going to look at arithmetic sequences today. And so this is a certain type of sequence where we have something going on that doesn't happen in the other kind. So if you have an arithmetic sequence, this is a sequence that has a common difference. And so what this means, if there's a common difference, the difference between any two successive terms is the same. So if you take term 3 minus term 2, or term 2 minus term 1, you get the same answer. And so it's a common rate of change. You could think of it that way. So here's some examples of sequences with a common difference, or arithmetic sequences, in other words. So if we have 8, 10, 12, 14, do you notice every time we're just going up by 2? And so our common difference in this particular sequence right here would be 2. All right, another example. You're going 4, 10, 16, 22. We're increasing by 6 each time, so the common difference is 6. Now I wanted to do one like this because nothing states that the common difference has to be a positive number. And so do you notice this one? We decrease by 4, decrease by 4, decrease by 4. That's still an arithmetic sequence. The thing that changes is the common difference is negative. And so D, or a common difference on this arithmetic sequence, would be -4. All right, so there's some examples of arithmetic sequences. I want to give you a couple examples of sequences that are not arithmetic. And so if you look at this one, the difference between successive terms here is 3. The difference between successive terms here is 12. Automatically, we just look at those two and say, this doesn't work. This is not arithmetic, because arithmetic means the difference between successive terms is always the same thing. It changes, therefore that's not arithmetic. Same thing here. You went up by a half to get from 1 to 1/2. From 1/2 to 1/3, or sorry, you went down by a half to get from 1 to 1/2. From 1/2 to 1/3, you did not go down by a half, that would be 0. And so this is not arithmetic either. So there's some examples of arithmetic, there's some examples of not arithmetic. Now, let's think about how we work with these. There's a formula for how we can get any specified term on this without counting all the terms up to it. But I don't want to just tell you that formula. I want us to logically reason through it, because I feel like this is one where if we just think about it, we could come up with it. And then if you get stuck and you don't remember the formula, you really don't need it. So let's see if we can find the 450th term of this. I wanted to go with a slightly larger number to kind of try to get you guys to not just count the first however many terms. Because if this said find a 20th term of it, you might be tempted to just say, all right, well, I've already got 4, so let's just keep going up by the same amount until we get to the 20th term and we're good. You could do that here, but to get to the 450th one, it's going to take a long time. So let's not do that. So instead, let's think about what we have going on here. Well, first thing we need to think is how much are we going up by each time? So this has a common difference of 3. Notice 8 plus 3 is 11, plus 3 is 14, plus 3 is 17. So our common difference here is 3. Now let's try to think about what we're doing to get a certain term here. So we're repeatedly adding 3. What's another math term for repeated addition? If I did 3 plus 3 plus 3, then isn't that really just the same thing as 3 times 3? Repeated addition is multiplication. That's going to come into play here with our thinking. And so we're adding 3 a bunch of times. And so if I want to get to the 450th term, we need to think about how many times do I need to add 3? And we need to think about what am I adding it to? Because if you notice, our starting term here is not 0. Our starting term is 8. So let's see if we can make sense of what's happening here. So we're starting at 8, and we're adding 3 a whole bunch of times. Now, here's what we have to think. How many times am I adding 3 to this to get the 450th term? And I think a good way to think about this is just think about what we did on these first couple terms. Now we started at 8. How many times did I add 3 to 8 to get 11? Well, we only added it 1 time. So to get the second term, this is term 2, and I tell you what, I'm going to put the indexes here to help out with this. That's our first term, second term, third term, fourth term. So to get to the second term, we added 8 once. Or we added 3 once. So to get to the third term, how many times did I add 3 to 8? Well, I started here, I did 8 plus 3 one time, plus 3 a second time. So to get to the third term, I actually added 3 twice. And so we didn't add 3 at the first term. This is where we have to think about it. Your first reaction, a lot of people say, well, this is going to be 450 times we need this. Well, when we were at the second term, we only added 3 once. When we were at the third term, we only added 3 twice. Do you notice it's 1 less than whatever term we're on? Because we don't add 3 at all on the first term. And so we're going basically from the second term on. And so to get to the 450th term, we need to add 3 449 times. And so instead of just doing 3 plus 3 plus 3 plus 3 449 times, repeated addition is multiplication. And so another way to say this would be, this is 8 plus 3 449 times, or 3 times 449. And so I'm going to do this. We've got 8 plus 3 times 449, which gives us 1,355. So that is our 450th term, or we could call it a sub 450 in this sequence. Now, let's see if we can generalize a formula from what we just came up with right there. To find the nth term, or I tell you what, let's even go to find the 450th term, and then we'll generalize farther to the nth term. Think about what 8 represented. 8 represents our starting point, our first term. So we did our first term plus, what does the 3 represent in this? Well, 3 is our common difference. That can change problem to problem, but in this case, it's 3. And so we did our first term plus the common difference times 449 in this case, which is really just 1 less than whatever term we're on. And so to say a sub n, remember n is the number term we're on, we're going to do a sub 1 plus the common difference n minus 1 times. Because to get to the 20th term on this one, for example, you would add 3 19 times. It's always 1 less than whatever term you're going for. And so now, from here, I could put in 8 for a sub 1, 3 for d, and then I could find whatever term I wanted to in this sequence by just plugging in that term for n. So to find the 80th term, for example, it would be a sub 80 equals 8 plus 3 times 79, because it's n minus 1 and n is 80 on this one. And so here is our general formula for how to find the nth term of any arithmetic sequence. All right, so things to keep in mind here. Arithmetic means we're finding that we have a common difference. We're adding the same number or subtracting the same number. Remember, it could be positive or negative. And the common difference can also be a fraction. It doesn't have to be a whole number. And so that's what the common difference is, and that's what makes it arithmetic. To find a general term in one of these, or a formula, which is what our general term means, is we take whatever term we're after, we do the first term plus the common difference, n minus 1 times. So if we're after the 80th term, that's 79 times, and there we go. There's our general formula, or our nth term, for any term we want of that without counting all the way up to it.